All right, time to start talking about polarity. So, what is polarity? Well, polarity is the property of having poles. Makes sense. Think about like a magnet, poles on a magnet, positive and negative, right? In chemistry, very similar, something is said to be polar if it has a negatively charged end and a positively charged end. So, if we have a molecule that is made up of two atoms, where one is relatively positive in charge and the other is relatively negative in charge, and they are linked together or bonded together, this would be a polar molecule. And the same thing would go if we were looking at a molecule kind of configured like this, right? Even though it's a different shape, it still has a positive end and a negative end. Tying things together, I want to shift your focus to the word charge. What's a concept that you know that is directly related to an atom's or element's charge? Specifically, it is related to an atom's number of protons it has, meaning the amount of positive charge it has because protons, remember, are positively charged. Right! Electronegativity. Now, just like what you learned before, when going through the different kinds of chemical bonds, such as our nonpolar bonds, our polar bonds, and our ionic bonds, where the numbers above each one of these items tells us the difference in electronegativity between the two atoms or elements we're looking at. If two atoms or elements are very close in electronegativity, right, such as what we see up top, less than 0.5 difference, we would consider the bond between the two of them to be nonpolar, right? The same holds true when you're trying to determine if the overall molecule is polar or nonpolar. So let's dive into that a bit. To be considered a polar molecule, the molecule must meet all three of the following criteria. But keep in mind, a lot of these criteria are actually dependent on one another. So sometimes if you meet one of these criteria, it actually implies that you must also be meeting at least one of the other ones. So that's just something to keep in mind. But looking at this, the first criteria that must be met is that the molecule, the difference in electronegativity between the elements within the molecule must be greater than 0.5. The second one is that the bonds between the elements must either be polar or ionic. And that makes sense because if the electronegativity difference is greater than 0.5, that implies that the bonds between the elements within that molecule are already either polar or ionic, right? And lastly, when looking at the physical structure of the molecule, one end of the overall molecule must be a different overall charge than the other end, meaning one end should have an overall positive charge, while the other end should have an overall negative charge. So let's look at water as an example. When we go to our periodic table that shows us the electronegativities of each element, we see that oxygen has an electronegativity of about 3.5, while hydrogen is about 2.1. So the difference between oxygen and hydrogen in terms of their electronegativity would be 3.5 minus 2.1, which is 1.4. So looking back at our criteria, this first criteria is the difference between the elements within the molecule in terms of their electronegativity greater than 0.5? Yes, right? 1.4 is greater than 0.5. The second one, are the bonds between the elements polar or ionic? Yes, right? We know this because when we are dealing with elements within a molecule that have difference in electronegativity between 0.5 and 1.7, we are dealing with a polar bond, right? And lastly, is one end of the molecule a different charge from the other? Yes, right? I sort of gave this one away in my drawing of the molecule, But since oxygen is so much more electronegative than hydrogen, we can assume that oxygen would hold more tightly to the shared electrons between the oxygen and hydrogen. This would cause oxygen to have a partial negative charge, while the hydrogen would have a partial positive charge. Make sense? So we can see here that at this end, we have our positive hydrogens, or our partial positive hydrogens, while at this end up top, we have a partial negative. So even though it's not arranged in a straight or linear manner, so it's not necessarily totally clear where the ends are, we can see that this would be considered one end and it's positive, and this would be considered one end and it's negative. So that does meet that final criteria. Now it's time for you to apply what we've learned on your own, okay? So this is check-in number 13, so make sure you're looking at number 13 in your assignment. Sound good? Now, looking at the molecule presented to us, we have a chlorine bounded to a hydrogen to make one molecule. Is this molecule polar or nonpolar? Keeping our 3 criteria in mind. Check-in 14. Is this molecule polar or nonpolar? And finally, check-in 15. Is this molecule polar or nonpolar? So circling back to our original question, moving forward, we're going to really focus in on water specifically, since the properties of water are what allow life to be so sustainable on Earth. So let's do a deeper dive to answer the question as to how water's properties allows it to interact in certain ways with other molecules and how it is so integral to the supporting of life.